Welcome, everyone, and thank you for joining OPSWAT's webinar today on Unified Resilience for OT. I'm Ankita Datta, Senior Product Marketing Manager here at OPSWAT, and I'll be your moderator. So, a quick update about us. We are OPSWAT, and because everything we are discussing today is grounded in what we do, OPSWAT has been in the critical infrastructure protection business for about 20 years. We protect some of the world's most sensitive environments. So this covers nuclear facilities, energy grids, water, wastewater defense, etc. And our platform is purpose built for IT/OT convergence, meaning we don't just adapt IT security tools for OT, we build specifically for the constraints and consequences of OT environments. So I would like to take a few seconds to introduce our speakers for the panel today. We have Itai Glick, who is our General Manager for Hardware and OT Security. Itai leads the team that's building the technology that we'll be discussing today. We also have Mark Toussaint, who is our Principal Product Manager for Network Security and Data Transfer. And we have David Young, who is our Principal Product Manager focused on endpoint protection, transient device security, and removable media. Itai, Mark, and David, welcome to this session, and we're hoping to have some great insights from you today.
Thank you.
Thank you.
So moving over to the first topic of discussion here, Itai, I would love for you to ground everyone here before we get into the details. When we talk about critical infrastructure, what exactly defines these environments? And more importantly, what makes them so uniquely difficult to protect compared to your standard enterprise IT environments?
Okay, thank you, Ankita. So let's go on what we mean by critical infrastructure. We are talking about the system where a cyber incident isn't just a data breach. It isn't just records going out or some confidential data going out, which is of course bad, but this means that a pump doesn't work, a turbine doesn't trip, a train signal gives you a wrong indication. So power grids, water treatment, oil and gas pipelines, transportation networks, pharmaceutical manufacturing, defense facilities. And the defining characteristic of this industry, it's just not the same consequence like IT. It's a failure in physical world of something that might and will affect. That's why it's completely different state of mind when we're looking to protect it. And what makes those environments uniquely hard to protect compared to standard IT enterprise, which has its own challenges as well, is that the assets are old. They're using Windows XP HMIs, PLCs from the 1990s, controllers that were certified and never even thought about security in mind, and nobody think about how they can patch them without recertification, without downtime. And second, the operational priority is availability, not confidentiality, making sure that everything continues to work. You cannot just turn down a boiler. You need to shut down the entire plate to do an update. So when we talk about OT security, we're talking about how to protect environments where every IT security playbook is wrong and doesn't hold. So this is our challenge. This is what we want to explain today in the webinar, how we can achieve that security for the OT infrastructure.
Yeah, and we know that OT is not designed to be secured the way IT is. So, Ida, I would love for you to walk us through that. When you look at industrial control systems, what are some constraints that make standard security controls either impossible or actively dangerous to apply?
So I think that the worst case incident is a process that runs out of say parameters. Okay, you start to do a chemical procedure and at the end it goes wrong. The difference is that this can cascade into every defensive choice. In IT, you can just say, okay, you know what? It's Tuesday, Microsoft just put a patch out. Let's secure ourselves and patch. In OT, you cannot turn it off. You cannot stop the process. You need to do a full shutdown that happens sometimes once a year, sometimes every 5 years, and you need to schedule it in advance, and that's one. You cannot deploy an EDR agent or an endpoint detection and response agent on every endpoint, because in the case of a problem with the EDR, your entire process goes down, and you cannot take that risk. It's not like saying to somebody in the IT world, hey, yeah, we had a problem with your agent, just do a restart and everything would be fine. No, you just created more harm than an attacker by doing that. So you need to have that in mind. And also, in a lot of the cases, today in Windows, you can install whatever you want. But if you're running a controller by a vendor, it's not your device. As soon as you touch it, as soon as you make any change of that device, you lose the vendor warranty. And nobody wants to take that risk. So you cannot even install third-party security mechanism on your devices when they are so needed to protect your organization. So we saw that the devices and the equipment is different, and the KPI is different because the KPI of the plant manager is uptime. It's not security. It's not confidentiality. He wants to make sure that the factory keeps on working every day. So whatever you do that breaks that for him, he would reject it. So it's completely different than what we see in IT. You can't run the IT playbook. You have to design controls that work without agent, without patches, without disrupting the process. That's why it's so difficult.
Yeah, and I'd like to move this over to Mark as well. From a network security standpoint, how would you define what are key differentiators between OT and IT security, and maybe David as well for some inputs here?
Well, I think on top of what Itai said, we're not only dealing with different environments, different types of devices, different KPI measurements, but we add on to that industrial protocols, which typically IT does not understand the mechanics of how industrial protocols work. There's also the notion that if there is an attack, as Itai said, that we have risk of not only downtime, but we have risk of safety. If there are vulnerabilities that are attacked, people could potentially be hurt. So we need to look at, in terms of the concerns. I think that from my standpoint, one of the most concerning vectors is open ports and communications that are unknown, and that from an OT perspective, the users may not even know that they have vulnerabilities that open doors for attacks.
So a quick poll for all of our attendees: which are a few threat vectors that concern you the most in your OT environments? We look forward to your insights for these.
I think Itai already touched on the unique challenges around endpoint protection inside an OT environment. Often they're older devices running operating systems maybe that aren't supported by traditional EDR software, or perhaps they're devices that can't have any resource utilization kind of contending with their primary process. So it's not an endpoint that can run a nightly AV scanner or something like that directly on it. So that brings additional challenges to how do you secure those endpoints. Beyond that, I think even the security that is often put in place to protect an OT environment that can look like an air gap can actually become a barrier to getting timely AV signature updates into a plant in the first place. So that brings an additional challenge of how do you make a safe data path and protect that critical data that's coming in.
Yeah, and we know that one of the most important shifts in the current threat landscape is that attackers no longer need malware to cause massive disruption. So they're living off the land using tools and credentials that organizations already trust. So the kill chain has changed fundamentally, and a lot of security teams haven't caught up to this yet. So Itai, could you walk us through how modern attackers are actually getting into OT environments today, and why traditional defenses are not able to match up to this?
Okay, I think that the way that attackers would go into the OT is first they can use the IT-OT boundary itself. If it's not protected, they can just hop on. And hacking an IT organization is something that they've been doing for years. Now, when they are able to hop on into the OT network, which is not built with security in mind, they just are able to bypass all the other security mechanisms because they're just like an engineering workstation working on the devices, and nobody would be able to see that. There is no security in place. And then another thing that happens, a lot of organizations want to digitalize everything, so they're moving things to the cloud. So all the controllers, a lot of the controllers are now directly connected to the internet. That creates a huge amount of possibilities for hackers to directly connect to them and do any change that they want. Another option, as I mentioned, the agent or the lack of agents is actually creating an opportunity. And if in the past we had very simplistic agents, protection agents installed on devices that were approved by the vendor, because everything moves so fast now and the attackers are becoming more sophisticated, that agent that just doesn't keep up. We need more technologies, we need AI, we need sandboxing, we need preventive technologies, and they're just bypassing it because they're smarter. They use a polymorphic malware and they're in. So I see those three vectors as the major one. And finally, attackers needs to be blocked. We need to prevent them to even getting for the OT network. We'll talk about it more. Back to you.
Any, Mark and David, any inputs from your side for this?
I think what we see often in terms of, how attackers bypass traditional OT defenses, the most secure way of protecting your OT environment is with an air gap. Unfortunately, air gaps are not practical because the business side or the IT side needs access to that OT data. So how do you secure that OT environment? Many companies out there are using firewalls and have a sense of security that they have a firewall between their OT network and their IT network. Unfortunately, firewalls are vulnerable and can be hacked. You just need to do a search on the internet on the firewall breaches, and you could see, that breaches happen all the time with firewalls. Why is that? By their nature, firewalls are bidirectional and they share routable information between networks. So there's no network confidentiality between the OT network and the IT network. In addition, firewalls are software-based and rules-based. So they're very prone to misconfiguration. We see instances where a customer may have, 600 firewall rules, on a firewall. What's the likelihood that if you have to manage 600 rules that you're not going to make, mistakes and do things like leave ports open? So often attackers bypass traditional OT defenses with, getting around the false security that a firewall is good enough.
I think also we are seeing attackers target interfaces or systems that are on the periphery of the OT network. So while the OT network is air-gapped and well protected, they often find vectors for attack that are bordering the OT network on the IT side through some sort of malware attack that's able to be transited into the facility via USB drive, sometimes not even the organization's network itself. It could be a hotel network or even the personal USB drive of somebody who's visiting the site. So they're finding unique ways to infiltrate the organization.
Yeah, and if you talk about what a typical OT attack looks like, maybe Mark, David, you could add some insights on what happens when an attack cascades from IT all the way into production shutdown, and what a typical OT attack would look like.
Well, I think that, when we talk about damaging OT attacks, we often think about, very sophisticated nation state attacks, which do happen. We know that, certain nation states are targeting critical infrastructure around the world. But in some cases, it's very basic things that allow a damaging OT attack. For instance, last year, there was an attack on a small water utility in Pennsylvania that gained a lot of notoriety in the news here. And, it really wasn't a sophisticated attack, the attackers did port scanning and found an open port, and then they found a PLC that was using default credentials which are available on the internet, and were able to breach that network and cause damage to the water treatment facility. So there's a broad range of attacks that can be very sophisticated but very basic. So there's a wide range of anatomies that are out there that can damage OT networks.
David, anything you would want to add here, or Itai?
Yeah, I think in the removable media realm, of course, Stuxnet is the classic and perhaps often overused example of a removable media attack. This was the 2010 attack against an Iranian nuclear enrichment facility where some malware was able to infiltrate on a USB drive and target a device, causing it to spin out of control, all while sending back to the operators of the device positive signals that everything was working fine, and ultimately destroyed the device. We see these kinds of attacks continue and sort of grow both in complexity as well as how prevalent they are. They're no longer just targeted attacks against one organization in a very specific scenario, but they're broader attacks sort of created just to generate instability in the marketplace, perpetuate ransomware attacks, things like that.
Yeah. Ita, anything you want to add?
I think one of the things that we can think about is today, especially when the OT is maybe segregated, maybe not connected, there might be a possibility to even use AI inside the malware to analyze and decide on his own what would be the next step to target, what vulnerabilities to find, and propagate inside the network. So we will be able to see more attacks, or we'll be seeing more attacks like that.
Sure. And which brings us to the main crux of the conversation today. We do want to focus on what unified resilience is and why it matters. So, Itai, could you give us a quick glimpse of what, according to you, is unified resilience and how companies can achieve this?
So in OT, and I would say in IT it's also, but in OT is even further emphasized. The resilience means that you cannot suffer even one attack. Okay, you cannot suffer somebody in your network for a few seconds, and this means that you need to think about prevention. What do I do before they get in? How do I prevent them from getting into the OT network? How do I prevent them from getting into the endpoint? Because when they're on the endpoint or where they're on the network, especially in OT network, they won already. Okay, because the OT is not designed with security in mind. As soon as they're in, they can do whatever they want. So we need to make sure that we prevent them from getting near us. And that's what we'll be talking more.
Yeah. So basically, like putting together a lot of different solutions that can work together to protect OT. And I think I would like to take this to Mark as well. From a network and data transfer standpoint, what does your piece of that unified resilience picture look like in a real deployment scenario? If you have a customer coming to you asking, okay, we have firewalls between IT and OT, where do you start the conversation about what they're still missing?
Well, I think that, from a unified resilience, we've got as Itai said, the protection. You've also got data protection and business continuity that are considerations into the unified resilience model. From my perspective, one of the components of that with protection is how do we secure the network boundary between OT and IT, or even deeper, individual devices or assets, to ensure that nothing can attack the OT network. And as I mentioned before, air gaps are not practical because the business needs access to that OT data. So we do things like deploy data diodes and security gateways, at the network boundary to ensure that that data can move unidirectionally, but there is no return path for data to move back into OT. and potentially provide an attack surface within that OT network.
Yep. And David, so when you look at unified resilience, what's the control that most organizations think they have covered but actually don't?
When it comes to removable media, I think often customers have policies around removable media, but sometimes those policies have allowed or expected exceptions. So I would challenge organizations to think about how they're controlling those exceptions, if they're able to validate and audit them. And I also think that transient assets, such as a contractor bringing a laptop on site or somebody from a sales team visiting to give a presentation in a conference room, are vectors that perhaps aren't always considered when building a unified resilience approach to security in the OT network.
Interesting. So we've talked about the IT/OT boundary as a architectural problem, but let's get more concrete about how IT becomes the attack path, because sometimes the entry point isn't the vulnerability. So, Itai, maybe we can start with you here. Can you walk us through how IT becomes the causality path, and why CISOs, etc., can't trust their own IT network sometimes?
Getting into IT is within the different capabilities or different methods that we see all the time. This could be a unpatched device, it could be an email phishing, it could be you go to the wrong website, and eventually your computer is compromised. Now the attackers are looking to see how they can get to the OT network, so they would start to see, they would start to propagate in the organization. They would want to find one of your engineers, and they would infect his device, because they would suspect that from his device he would be controlling the OT network. So this threat is related especially to OT, because as soon as you're in the network of the OT, again, you see all the devices, and with some of them in Windows XP, you are vulnerable in critical ways to getting compromised. Because you couldn't patch it, because they're really old, because you thought that they're in a segmented network, they got hacked. Okay, whether it's an RDP vulnerability from 2018 or whether it's a vulnerability from 2007, you still get to those devices. So the threat is using actually very, very old vulnerabilities that are a commodity today to hack your OT devices, whether it's a Linux device, whether it's a Windows device. As long as you didn't take care of patching, they would get there. And of course, some of the protocols that are used by OT are not even secured. So again, you will find yourself without any protection from the sophisticated threat that is looking for the OT network. And he's already done his first step in your IT environment.
Yeah, and I do want to connect the dots before we move forward to the how. Like we've spoken about threats coming in, attacks coming in from IT, and then this often includes like through trusted tools, supply chain dependencies, etc. So let's talk a little bit about what a mature OT security architecture looks like. So I'll open this question up to everybody. Mark, David, and Itai, what are your inputs, insights on what a mature OT security architecture looks like?
Well, I think that in the context of the unified resilience, it's really looking at the three pillars, whether that's cybersecurity and prevention. How do you protect your data? How do you ensure that sensitive data does not come out of the OT network? And then, in the event that there is a breach, how do you recover? How do you ensure business continuity? So looking at the in terms of mature OT security architecture, you're looking at those three components holistically, and not only looking at the prevention aspect, but the data. How do we protect the data? And then in the event that something happens, how does the organization recover, and how do we maintain business continuity? So it's really looking at the three components of unified resilience, and putting together a strategy, for all three of those pillars. Now, there's more to it than that, but those are sort of the major components that I see.
David, over to you.
Yeah, again, I would just mention that there are usually policies in place and solutions that have been put in place to address basic usage. Organizations often understand the basic threat that USB drives bring, so they attempt policies such as banning them, but then they have to make exceptions for legitimate required uses of USB. So organizations should think about ways that they can mitigate the risk of those exceptional cases and put controls in place to manage them and to be able to audit on them.
Yep. Ita, anything you want to add here?
Yeah, just at an angle of compliance, there are some compliance regulations that demand segmentation. For example, IC 62443 model is saying that the OT needs to be segmented in a different zone. So it's already identified as something that you need to do and you need to be mature at. In parallel to that, also for the removable media that David has mentioned, this is again mentioned in a lot of the compliance regulation like the NERC SIP and ISO that you need to make sure. And finally, the ISO also mentioned that you need to patch your devices. So in order to maintain your compliance and to really be an organization with high maturity, you need to make sure that you have all of those capabilities or compensating controls available.
Sure. And now that we've covered so many of these different topics, I would like to start focusing in a little bit on IT OT boundaries. So, Mark, with the architectural framework in mind, from your experience and conversation with OT customers, currently, do you see if there's a clear visibility into what is currently crossing through the IT OT boundary for customers, not in theory, but also in practice?
I don't, and here's why. I was at an example I like to talk about. I was at the Distributech trade show several years back, and I watched a presentation where an OT engineer, they did an audit of all of the inbound and outbound connections in their network, and they had something like 139 connections inbound and outbound. Many of them they were completely unaware of. It could have been that they had a vendor that they provided for remote access, and then that vendor was no longer utilized and left an open port. So there are a lot of threat vectors that they were, even unaware of. So, when I talk to customers about, how do we get started in terms of protecting the OT boundary, the first step of that is understand what data flows are going in and out of the OT and IT networks. Now, there are, well-tested solutions for, managing the flow of that data across your network boundary. But the first part of that, whether you're looking at utilizing data diodes to protect that network boundary, the first part of that is really understanding what data moves across your boundaries today. And just as important, what assets within that OT network are the most important to protect? For instance, when we engage with customers, often, in terms of network segmentation and data diodes, a lot of customers, the first thing they come to us for is how do I secure my Aviva Pi database? And that's really important because the Aviva Pi system historian aggregates data from a wide range of assets and networks and really becomes the go-to source of information in that OT network. If that database is compromised, the OT has no visibility into their processed data. So it really comes down to understanding, what data flows are moving out of OT and into OT, what assets are really important to protect, because there's a lot of paths you can take to protect those networks, but really we need to focus. Customers are challenged that they may not be able to do everything at once, but by looking at those data flows and then asking, what are the most important assets that I need to protect first? That gives us a roadmap to, how we address that data that's crossing the IT-OT boundary.
Interesting. And Mark, we've spoken about visibility into the kind of data that's flowing. Another topic of conversation and concern is the update path, which is most critical and almost always most underestimated as well in terms of attack surfaces in OT. So, could you tell a little bit more about how do you push software updates, patches, and firmware into OT networks safely? And when the transfer path itself is treated as untrusted. And I'm sure David would also have some inputs to add here.
Yeah, I think you talk about the peripheral media aspect, but there's any number of ways to move data from IT into OT, whether it's software updates, patches, operational files, and then, there's really two components to that. How do you ensure that the data or the files that you're moving from IT to OT are secure? Have they been sanitized, and can we ensure that there's no compromise within those files? So, assuming that we have technology to sanitize those files, whether it's AV multi-scanning or content disarm and reconstruct technology, the second component of that, in terms of we've looked at our files, we've sanitized them, we have known good files that we want to move across the network boundary. Now, how do we secure the transfer of those files from IT to OT? And we deploy a range of products, but most often optical data diodes, to ensure that we move those files with hardware enforced unidirectional data flow. And what that means is we've got those sanitized files, we've moved them over the network boundary, and those files can be ingested in the OT environment. And then the context of what the data diode is providing, not only providing that network confidentiality, but ensuring that nothing can come back out of OT because the diode prevents a return path. And then I mentioned that there are many ways that files come into organizations and then move from IT to OT. One of the most common use cases is peripheral media. And I'll let David talk about some of the challenges and benefits of technology in securing those data flows with peripheral media.
Yeah, thanks, Mark. I'll share a personal anecdote. I was working with a customer once on an evaluation of a kiosk product, and they were doing some testing with it and came back and complained that they were getting a false positive. And the operator was adamant that they had downloaded a vendor patch directly from the vendor's website and confirmed the hash of that patch, so they knew it was legitimate, moved it onto a USB drive, and then the kiosk was claiming that it had malware. And upon doing further investigation, they uncovered the fact that as they transited that file across their network to a file share and then onto the USB drive, that patch from the vendor was actually picking up a very dangerous piece of malware that attacks safety systems. So in this scenario, the customer was following their process and believed they had all of their bases covered, but there was this small sort of crack on the IT side that could infect a file just before it entered the OT network. And obviously it really proved the point to the customer of the importance of scanning at every opportunity and revalidating the content and disposition of those files before you actually let them come into your OT network.
One thing I would like to add here is that part of securing the software update path is not only making sure that the file gets in properly, it's also deploying and implementing the patch at the time that is right for the organization without risking the organization even more. For example, ring-based patching. So you're able to verify that the patch doesn't impact some of your controls before you do it for the rest of your factory. So this is also part that I see is to secure the update path, because Windows Update would just do it automatically every monthly Tuesday. But in an OT environment, you want to make sure that you're doing it securely and without bringing more damage to your organization.
Sure. Thank you for the inputs. Itai, and we touched upon segmentation in the beginning of this presentation. So, Mark, let's talk about this being as one of the most expensive misconceptions in OT security, the belief that network segmentation equals protection. We've seen organizations that invest significantly in segmentation using VLANs, firewalls, DMZs, etc. But as per your experience, I believe segmented it does not always equal security. Could you walk us through why segmentation and hardware enforced air gap are fundamentally different things and what it actually costs?
Well, we've seen customers that believe they have implemented an air gap, and on further review, find that they have, as I've alluded to before, open ports. They have vulnerabilities that they're unaware of. So just because you think you have an air gap, you may not. And as I've said again, that business needs access to the OT data, so air gaps are not practical. So we look at segmentation from a number of different areas. First is at the OT IT network boundary. How do we secure that boundary using things like data diodes to ensure that we have unidirectional hardware enforced one-way data flow from OT to IT. So we have that data available for business analytics, predictive maintenance, things like that. Yet there is no threat vector back into that OT network. Now, when we engage with customers, often the first thing that they want to look at is, how do I protect that OT network boundary? And as I mentioned, we do deploy data diodes for that. But deeper into the Purdue stack, we want to look now at microsegmentation. So customers may want to protect, in addition to the network boundary, they may want to protect an individual asset, a single PLC. So we can deploy security gateways and diodes to do that. But then there's the other aspect of, how do I continue on with microsegmentation between my different assets? And we deploy things like industrial firewalls deep into the stack to prevent lateral movement. I had a customer tell me once that, of course, they're worried about external attacks, but they also worry about non-malicious acts by employees, by making mistakes, making accidents where they can cross network boundaries or jump between assets and inadvertently make changes that impact the process and equipment. So there's really three components that we look at from the segmentation aspect. How do I protect that network boundary from OT to IT? How do I protect individual assets that may be really, really critical to the operation? And then how do I prevent lateral movement within that, within the networks?
And I think even before we get to the segmentation aspect of it, we have a tagline that is often used, which is like, you cannot protect what you cannot see, which leads me to my next point of conversation, which is around detection and containment inside OT. So let's talk about a scenario where prevention wasn't enough and the attacker is already inside the OT network. Itai mentioned legacy devices in OT. We know that there are a lot of OT networks where devices have been hidden in the corners for decades um, uh, being without actually being discovered for a long time. So detection in OT is fundamentally different from IT. So Itai and Mark, could you walk us through what detection and containment or protection actually looks like in an OT environment?
Okay, I'll touch two aspects of this, and then Mark, you can follow on. So detection in OT is completely different from IT. First, because in the IT detection of a threat, you're basing a lot of the analysis on the endpoint detection response tool that you have on the device itself. In OT, those agents are not available or are not installed by definition. And again, as mentioned earlier, if you install them, you'll void the support warranty that you have from the vendor. So the detection need to happen in the perimeter, You need to a deep inspection of the perimeter as much as you can. For example, with multi-scanning, with sandbox, with vulnerability assessment, to make sure that you're preventing it from entering your perimeter. You also can detonate it in a sandbox, and again, everything in the perimeter before it gets into your organization, before it starts to be evasive and malicious and taking things down. The second aspect is OT network detection. Once you're inside the OT network, it's not the same protocols. It's not the same devices that you see in the IT. So you need to make sure that you understand those protocols, you understand the vulnerabilities, you understand the functions, and you bring up a solution that detects it and shows you anomalies of that. So you need to deploy monitoring that understands Modbus, IC, DNP, and flags anomalous behavior. And you can also combine it with bypassing of zones in your OT network. So this will give you a little bit more about the detection. And now, Mark, to your side.
I mean, in the event that you did have an incident where you had malware or something that reached the OT network, I mean, there's a couple of areas. I just touched in detail on the, 3 types of network segmentation, really from, the containment aspect of, if something gets inside, I maybe have, individual devices, diodes and things like that are protecting critical assets, but also preventing lateral movement. Often when we engage with customers, as I mentioned, one of the first things we do is we look at, how do we protect that network boundary? And, assuming a customer understands, what data flows are coming in and out of that network, we can deploy a data diode at the network boundary that even if you have some sort of breach, inside the OT network, let's say you had some peripheral media that infected something, a diode prevents, a phone home situation. So, that malware may reach out to the IT network, but because we have a diode at that boundary, there is no back channel into that OT network. So even if there is compromise within OT, there's no back channel so that there can be a phone home round trip to have that negative impact on the OT network.
We have a quick poll for our attendees here. A few seconds for them to give their answers. And while we have this on, I would like to take this to the next section of our webinar today, which is going to cover removable media. And I think this is going to be David's area of expertise. So, David, let's talk about the physical boundary that is removable media. So we have USB drives that are operationally embedded in how work gets done in OT. We have engineers who use them for transferring data, updating PLCs. So what does a real removable media security program look like, according to you?
Sure. I mean, obviously, if you've got an air gap, even if it's sometimes a little bit mythical, the primary vector for bringing content in needs to move to removable media. And it's important to have devices in place that will allow operators to easily move their data in and out of the facility through approved channels with approved controls that's as frictionless as possible. We know the operators in OT environments are primarily focused on productivity above all else. They typically do understand the risk that is brought by malware, and of course are not unaware that malware could lead to significant productivity impacts. But in their day-to-day, sometimes they might even unconsciously take some shortcuts that introduce risk that they don't realize. So having things like kiosks in place so that every person entering a facility has to scan the removable media on a kiosk is an important aspect of this. Also, to the extent that you can use agents, some agents can be very useful inside the facility to help with any potential lateral movement of malware. Oftentimes on engineering workstations, you can't run resource-intensive agents that might be doing traditional malware scanning, but you could run a smaller agent that is able to at least ensure that any USB drive plugged into that workstation has been through a kiosk and has been scanned. So that can help prevent somebody forgetting to scan a drive, or thinking that the drive's already been scanned, or they confused the two drives they have in their pocket. And what we've seen out there, as far back as 2023, we see that threat actors are targeting this vector, and they're oftentimes doing it in novel ways. So we saw Sogu and Snowy Drive in 2023 were targeting oil and gas industry and some government engineering energy campuses. They were doing this by infecting PCs and printers at local print shops. So they weren't targeting the organizations directly or infecting the organizations directly. They were using these hotspots where employees might go to print out some plans and then pick up that malware and carry it back to their their facility, or take it even out to an engineering offshore oil platform.
Sure, we have another poll up here for our attendees. I'm sure we have sufficient time for those to be addressed. And we've spoken about removable media. Now, I think the next topic of conversation that is often a concern is transient cyber assets. So, David, again for you, we have contractor laptops, vendor diagnostic tools, portable test equipments. So each of these devices is potentially a bridge between different OT environments. And a lot of times organizations do not have a fast way to verify them before they connect. So
Sure.
we know that NERC compliance is adding urgency here. There are fines per violation, which is up to like $1.5 million per day. How do you say environments and CISOs, etc., could solve for this security requirement that comes with transient cyber assets?
Sure. Transient cyber assets are often overlooked. Certainly some industries, particularly the utility industry, is ahead of the game on this and has regulatory or compliance controls around this. But for some industries, they haven't even really considered that the contractor might be stepping up to their kiosk and scanning the USB drive the contractor's bringing in, but there's also a laptop in his backpack. And maybe he doesn't even intend to use that laptop, but once he gets in, he finds a need to do something. He connects to a hotspot on his cell phone, and quickly you've opened up a vector for attack that maybe you're not even aware of. So having a policy to scan all transient assets on the way in or not allow them in the facility is certainly important. There are products on the market, including one offered by OPSWAT, of course, that you can use to scan an entire laptop before that laptop's allowed to enter into a facility. So you can have some confidence that there's not malware pre-existing on that device.
Sure.
One of the things that is important here to look at is, even if the vendor comes in and say, hey, I have a laptop, I have antivirus on it, it's installed, you still cannot really trust that device. Okay, it's better that you scan it with your own set of antiviruses. You make sure that this is a clean computer, that the OS is not compromised. So scanning a transit asset is extremely important. Now, I'll tell you a story that I heard from one of my customers. They had a vendor coming into their organization, and he came in with his device. They didn't scan it because he was not planning to connect it to the network or to use it for his actual work. He didn't want to get stuff out. But what happened is he came into the organization, he connected it to the docking station. So he would enjoy a keyboard, power, dual screens, things like that really make your life very, very comfortable. What he didn't see, and what they forgot, is that the docking station has a network cable inside. So immediately he was in the network. He didn't even know that he's going to be in the network. He didn't want the network, but it just happened. So mistakes happened. Like they would say, if you don't need the device, put it outside. If you are needing the device, scan it before you get in.
Sure. Thank you, David and Itai, for your insights. So we're coming to the close of this session today. Just a few quick points, David, from you. Like, could you walk us through what prevent before execution technically means. So we know there's content disarm and reconstruction, there's sandboxing, etc. Why that intervention has to happen at the entry point rather than on the machine.
Sure. Yeah. Some of these attacks are things that could not be detected by traditional EDR on an endpoint. And they often take approaches to reach out and attack devices on an OT network that maybe traditional IT-focused EDR wouldn't recognize, whether they're custom protocols on the network or devices that EDR is just not prepared to handle. Certainly, as we've already talked about many times, oftentimes workstations are running older operating systems that aren't supported by EDR. So you need some way to protect at the perimeter before this content gets into the network in the first place. And it's also important to look at having something on the network, something on the perimeter like a kiosk that's doing multiple types of detection and prevention. So you already touched upon a few, certainly multi-scanning, traditional AV signature-based multi-scanning is very important, but you also want some additional mechanisms in place that can help you detect potential 0 days. So content disarm and reconstruction is a great technology where it actually looks at the content in documents that might be malicious. It's just a potential vector for attack and strips it out of those document types. So there's no risk that any kind of rich content could execute. Similar for sandboxing, right? Taking content into a environment that's set up to detonate the content and see how it behaves is an important prevention step.
Sure. And we have a last poll for our attendees. And while this is up here on the screen, I do want to have a few closing statements from Itai, Mark, David, from all of you. We've spoken about unidirectional transfer, peripheral media protection, segmentation, etc. So in a few quick points, like what is the single most important step an OT security team can take this year to move forward with the unified resilience plan? We'll start off with you, Itai.
I got the easy one. My view is that the single most important one is segmentation, true segmentation. Don't rely on any other equipment, and make sure your OT network is really segmented, because if there will be an attack, at least you'll have it somehow contained as much as possible, or you won't let the IT attack get into your OT environment. So start with that, start with the basics, and then start to figure out all the rest.
Yeah, I think, one of the biggest security challenges in OT is, and I may sound a little bit repetitive, but, it's important before we, move on to our journey of unified resilience that we understand what data flows are going in and out of IT and OT networks and what assets, applications are most critical to protect. And it can be very overwhelming for customers. I see customers that hire a security consultant who comes in and generates a report of 50 items that need to be addressed, to tighten up that OT network. From a cost perspective, it may not be practical that all 50 of those issues can be addressed, over a certain time period. So it's really important to look at and ask the question, what are the most critical things that I need to protect against? And then, look at that subset of issues, first, so that you can prioritize, what improvements are going to have the biggest impact on your security posture. So again, it can be a very daunting task, but, we need to understand the data flows that exist. And then, what is the most important to protect, to ensure, and really, in terms of the pillars of resilience is, what are the most things that are important? What are the most critical assets, applications, networks that I need to protect to ensure that business continuity in the event that something does happen?
Sure.
And I would,
And David?
sorry, I would just add, yes. I mean, assume every transient device, every piece of removable media is compromised until proven otherwise. And be sure you've got a workflow in place that makes it fast enough and frictionless enough that contractors and employees will actually use it. Oftentimes it's this gap between we have a policy and actually having enforcement where attackers find the openings by which they can infect an organization.
Sure. Thank you for all your insights, Itai, Mark, and David. This was a great session. Like, thank you for covering all of the details around unified resilience. Before we wrap up the session, I do want to let our attendees know that there is a resources section. For all our attendees, we have an interesting assess your ICS OT readiness test. Please do scan the QR code that you're seeing on your screen right now to understand better about where you stand with your OT security. And if you would like to get in touch with our OPSWAT team or get a hands-on demo for our solutions that we offer for OT security, please scan the QR code that you're seeing on your page or visit www.opswat.com. Thank you, everyone, for joining.